Well, I think we can all agree that the ocean is a pretty big place. It takes up more than 70% of the Earth's surface, and for all the size of it, there's really very little out there. And it's this emptiness of the ocean that creates big problems for ships when they go away from the coastline and out into the middle of the sea. They have these big problems with communicating and sending data back to shore. So the main reason for this is that the radio waves that we use for Wi-Fi and for mobile networks, they like to travel in straight lines. They don't like to curve around corners or go around bends or anything like that. So that means that whenever a ship goes out and travels beyond the horizon and goes beyond the curve of the Earth, they're essentially cut off from the rest of the world, which is a pretty big problem for a lot of the ships out there. So that's where the evaporation duct comes into play. So the evaporation duct is created by water evaporating off the surface of the ocean and creating a layer of humid air a couple of meters thick. And then as you go further up, the air dries out and becomes less humid. So this change from very humid air to drier air causes a sharp change in the refractive index of the air, and that's known as the evaporation duct. So what this means is that whenever you send out a radio signal, instead of just going off straight into space like it normally would, it actually gets caught in this evaporation duct and refracts around the curve of the Earth, meaning that you can get signals up to hundreds of kilometers beyond the horizon. So the evaporation duct has been known about for years by radar operators, and the US Navy did quite a bit of research into it. But it's only recently, in the past decade or so, that the technology that we use for communications has advanced enough so that we can use the evaporation duct to extend our communications beyond the horizon. So what I've been doing is I've been taking data from a number of weather buoys around the coast of Ireland and taking this data and calculating how often the evaporation duct occurs, and also whenever it does occur, how strong the evaporation duct is. So the results we've received so far are fairly successful. We're quite hopeful that it'll work, and we've also done some experimental work to try and confirm these results. So we went out in a ship with a transmitter on the back of it, and we were able to go out and receive signals up to 10 kilometers or so beyond the horizon. So while it's only a start so far, we're not getting too far, but it proves that there is something out there and there's something worth looking into. So it's worth looking into and doing some future research on. Thank you.